years. With the yearly cycle mapped out, settlements and agriculture could develop and early civilizations thrived. At the same time, the first maps of the sky grouped the brightest stars into familiar constellations, helping to develop navigational skills, expanding trade, and aiding exploration. But the first astronomers had no real concept of the order behind the patterns of the sky. These early scientists and philosophers were still bound by a view of the cosmos that was tightly interwoven with mythology. The ancient Greeks, with their rigorous intellectual approach, took the first steps towards separating the young science of astronomy from the ancient sky myths. The greatest minds of the age, such as Pythagoras, Eratosthenes, Apollonius, and Ptolemy, helped in developing a more complete scientific system capable of predicting astronomical phenomena. By observing the apparent motion of the celestial objects around our planet, the ancient Greek astronomers placed Earth at the center of the cosmos, creating the geocentric system. Aristarchus of Samos was the first Greek astronomer to propose a heliocentric model, placing the Sun rather than the Earth at the center of the known universe, but he was largely ignored for many centuries. It wasn't until the 16th century that astronomers such as Copernicus and Kepler revived Aristotle's view. By studying the astronomical observations of the Danish astronomer Tycho Brahe, supported by solid maths, the heliocentric system gained new relevance. According to this, all planets, including Earth, revolve around the Sun. However, the true revolution in astronomy took place in 1609, when Galileo became the first astronomer to turn the telescope towards the sky. In doing so, he broadened the horizons of the known universe and abolished once and for all the geocentric views of the ancient world. The telescope is an instrument that collects light and provides detailed images of remote and faint celestial objects. Seeing deeper and farther depends on collecting more light, usually requiring larger lenses or mirrors. Today, scientists have huge telescopes, supported by state-of-the-art instrumentation and sophisticated software to study the universe and discover its secrets. ESO's Very Large Telescope has 4 8-meter mirrors, and they can detect objects as they were just a few 100 million years after the universe began in the Big Bang. For the best results, these giant telescopes are most often located in remote mountain regions above much of the atmosphere and away from widespread urban light pollution. fog of time, to reveal a universe inconceivable to the people of the ancient world. A universe which is vibrantly active and violent, and where the game of life and death is played out on a scale that humbles all who observe it. In the last 50 years, we have reached out into space, leaving the bonds of gravity behind, and opened a new era of exploration. Thanks to the space program, we have seen our planet from an outsider's perspective, as a fragile, pale blue world orbiting the sun, frighteningly vulnerable in the cold and hostile environment of space. Space technology has altered our way of life and changed our perception of the world from a place defined by maps and borders to that of a small and insignificant body in space. The benefits derived from the space program have a value many times higher than the cost and effort involved. With space exploration came the technology that has placed telescopes above the atmosphere of our planet. Space telescopes that can record a fresh view of the universe, observing in wavelengths that cannot penetrate the Earth's atmosphere. Each new generation of telescopes, from Galileo's first simple instruments that showed us the moons of Jupiter, to the Hubble Space Telescope, has opened new windows on the universe and challenged our understanding. Step by step, we have been displaced from the center of the world and placed as exiles on the edge of a vast and inhospitable universe. Today, we know that the Sun is an average little star with a diameter of just under 1.5 million kilometers, and that it lies 150 million kilometers from Earth. The Sun is a sphere of gas, with a core where temperatures and pressures are so high that nuclear fusion is triggered, converting hydrogen into helium, all the while pumping out energy into space. Energy that warms and sustains the Earth, supporting life in all its oceans and across continents. Periodically, on the surface of the Sun, a localized strong magnetic field forms, creating a sunspot. Here, energy can accumulate, which is then often released into space in the form of huge explosions, known as flares. Particles flying out into space, sometimes reaching Earth and disrupting communications, as well as generating spectacular northern and southern lights. Currently, the Sun is in a very stable state and will continue to radiate energy at a steady rate for another 5 billion years or so. But eventually, the fuel powering the core will run out, and the Sun will slowly cool and expand to become a red giant, engulfing all the inner planets, including the Earth. Mercury is the closest planet to the Sun, a lifeless world with a very thin atmosphere.